All right, our last example, we're going to find the length of a chord with the information they gave us. It says find the length of a chord that is 12 meters from the center of a circle with a radius of 20 meters. So again, a lot of this is making sure that you're drawing the picture and understanding what it looks like. So here is our circle, here's the center. We have a chord, so wherever you want to draw in your chord, let's say I draw it in right there. There's our chord. It says it's 12 meters from the center of the circle. So if I draw a line from the center of the circle to the chord, remember that's going to give me a perpendicular angle, and they said that that distance is 12 meters. They said that the chord is 12 meters from the center. The other thing they told us that the radius of the circle is 20 meters. Well, remember, you can draw a radius in from the center of the circle out to any point on the circle. But to help us out, why don't we form a right triangle? So we're going to draw our radius from the center out to the end point of that chord, because now we have a right triangle. They told us that that was 20 meters. And they said, find the length of the chord. Well, remember, the chord is bisected, so we have two congruent segments. If we can find one of them, x, which is part of the triangle, see it's part of this triangle, then we're going to be able to double it to find the length of the chord. So let me take that triangle. I'm just going to go ahead, redraw it out here. We have 12x and 20. All right, so to find x, you have two ways that you can do this. I look at 12 and 20 and I say, oh, I could divide those both by 4. If you take 12 and divide it by 4, you get 3. If you take 20 and divide it by 4, you get 5. And then this looks like it's forming a 3, 4, 5 Pythagorean triple. So x is going to be the missing side, which is 4. But remember, when we do these Pythagorean triples, we divided by 4, so it's always helpful to write that down. So when we get the 4 from our Pythagorean triple, we're going to go ahead and multiply by that by 4, and we get 16 for the missing side of that triangle. All right. The other way to do that, if you did not recognize the Pythagorean triple, is the Pythagorean theorem. So going back to the original, we can say 12 squared plus x squared is equal to 20 squared. 12 squared is 144. X squared, 20 squared is 400. And then you just keep solving for x squared. You subtract 144 from both sides. X squared equals 256. When you square root both sides, you get x equals to 16. So if you recognize that a Pythagorean triple is involved, go ahead and use that. Otherwise, you can do a little bit more work and get the same answer with the Pythagorean theorem. Now, if we go back to our picture, we don't want to stop there, because to say x equals 16 doesn't actually answer the question. The question said, find the length of the chord. Well, we know that x is 16, but that's only half of the chord. The other half of the chord is also 16. So our total chord length is, we want to add those together. 16 plus 16 is 32. And do we have a unit on this? Meters. So for these problems, here are the key things. You want to draw a picture, draw in the information you had. So we were talking about a chord, and you're trying to figure out where you can get that right triangle with either a radius or a diameter in the chord. The distance from the center of the circle to the chord will always give you a right angle, and it bisects it, so it gives you those two congruent segments. So just some things to look out for on problems like this.